This is a 10-point FRQ. I'm just going to do part A and B, which is worth 4 points. The chemistry has got a little twist in it, but more importantly, I want to show you how a AP chemistry FRQ is graded in case you've done something wrong in an earlier calculation. That's important to know because that'll give you a strategy in terms of trying to collect the greatest number of points that you can on an FRQ. Well, here's the problem. Ethene, smelly flammable gas, they give you its molar mass, may be prepared by the dehydration of ethanol. That's just regular ethyl alcohol. And they give you its formula mass of 46 using a solid catalyst. The setup for the lab synthesis is shown in the diagram above. I'm going to have a little clip on how this is done by the chemistry shack, where somebody has a little shack set up in their house to do fun experiments. I'll have a link for this video that you can see. It's a fun one to watch, and this way you can watch the entire video. So here's a little video that shows how this experiment is done, where we take a test tube with some alcohol and a aluminum oxide catalyst and generate some ethene by water displacement. The ethanol is heated. Here you can see it start to boil. Here's some white aluminum oxide that the ethanol is going over and being changed into ethene, which is bubbling out of this tube. They're going to get rid of the air that was in the test tube at first. And once that happens, they're going to collect it in this test tube by bubbling it through the water, displacing the water. You can see the water is being pushed down. But there's an important factor here. As the ethene goes through the water, it picks up some water vapor, and we're going to have to deal with that. So take a quick look at this at the Chem Shack, and I think you'll enjoy it. So thanks to the Chemistry Shack, you can see how this experiment is done. It's a little bit messy, water all over the place, but that's sort of an experiment. Water displacement is fun to do. It's been done for centuries to collect gases. Even Lavoisier ended up doing this type of an experiment. Now here's the reaction. One ethanol with this aluminum oxide catalyst produces this smelly ethene and some steam. And it's an endothermic reaction. We got a plus, which is not favorable thermodynamically, but fortunately we have a entropy factor here that is an increase in entropy, and that's going to push things along, which sort of makes sense. This heat's going to help things. Entropy usually, because it's multiplied by temperature, can become more important when temperatures are higher. The student took a 2/10 gram sample of ethanol. Yeah, not much. Using the setup shown, the student heated the tube gently with a Bunsen burner until the alcohol evaporated and the gas generation stopped. They get rid of all the alcohol. When the reaction stopped, the volume of gas collected was 0.0854 liters, about 85 milliliters of gas, at a pressure of 0.822 atmospheres. Somehow they measured the pressure of the gas in here. 305 kelvins. Okay, it was a warm room. The vapor pressure of the water, wait a second, vapor pressure of the water, what's that got to do with things? That's where we have to be a bit careful. This is a warning. The vapor pressure of the water at 305 Kelvin is 35.7 torr. Water vapor pressure changes with temperature. Now, they want us to calculate the moles of ethene. Well, that's a gas. We've got a volume, we have a pressure, and we have a temperature, 305. So immediately you think PV equals nRT. And you say, I know how to solve that. I've done PV equals nRT many times, but there's a warning. You're trying to find the moles of this ethene. You've got a volume, pressure, and temperature. But let's look back at this collection. Here's the warning. Yes, here's the ethene and its volume, temperature, and pressure, but also there's water vapor here. And you're going to have to get rid of that water vapor. Whenever you collect a gas over water, you have to remove the effect of the water that's in here because you get a mixture. It's not pure ethene, it's contaminated. And that contamination has to be dealt with. And the way you do that is use this water vapor pressure that's given in the problem. Now, that water vapor pressure is 35.7 torr, but let's just change that to atmospheres, and then we'll have the pressure of the water that's in here with the ethene. So calculator time. So we'll take that pressure of the water. The water vapor pressure is 35.7. And of course, the change into atmospheres, we just divide by 760. I hope you remember that conversion. AP typically uses torr for a lot of their measurements, and you have to change them to atmospheres to use the PV equals nRT. So we'll do that division, and we get 0.047 atmospheres. This water vapor has this pressure, 0.047, and this pressure is in here along with the ethene, and our total pressure is 0.822. There's our 0.047, rounded off to 3 significant digits, and then we have to remove that water vapor pressure from our total pressure that we have. So I've got my total pressure, which is 0.822. That's the water vapor and the ethene, and I'll remove the water vapor pressure, and that's my second function answer. And this is the real pressure of the ethene. And notice they sort of give you a hint. Calculate the number of moles of ethene that are actually produced in the experiment and measured in the gas collection tube. So they say the actual amount, not the water in the ethene all by itself. So there is this subtraction. This subtraction is used whenever you collect a gas by bubbling it through water. You take the total pressure, remove the water vapor pressure from it that you get because it's given to you in the problem. When they give you water vapor pressure, you know you're going to subtract it from the total pressure, and that gives you the pressure of the ethene that's in here. This is the pure ethene without its contaminant. And we've got our calculator, and we know PV equals nRT. Find the moles of ethene. I'll take my P, which is now my previous answer, and I multiply that times the volume, which is 0.0854, divided by the gas constant, which is our 0.08206. That's given on the equation sheet, because that's going to be our equation here. Moles is equal to pressure times volume divided by R, and also divided by T. Don't press multiply by the temperature. You're going to get it wrong because that's going to multiply everything in our order of operations. Either use parentheses or you just divide by everything in the denominator. When you've got a multiplication and division, multiply by everything at the top and divide by everything at the bottom on your calculator. And in this case, our temperature is 305. I can double check because there's a lot of numbers here. I have my pressure of the ethene, pressure times its volume, 0.0854, right, divided by our gas constant. You've got to use the atmosphere liter mole gas constant, and of course our temperature. There we get a small number of moles, which we expect. We only had 0.2 of a gram of ethanol, so we're not going to get much ethene. There's the calculation. No, they were very good here. They included the atmospheres liter, the gas constant unit, and everything cancels out except for moles, which is our final answer. Yep, that's what we got, 0.00264, about 2.6 millimoles. Now we get, for this problem, 1 point for the dry pressure. They sort of hid this point in there. That's the water vapor pressure. They want to know if you realized about contamination of water vapor. And then you get 1 point for the number of moles of ethene gas. But let's say you forgot about the water vapor. You didn't notice it, and that's one of the details that you missed. Well, all isn't lost, because if you did this problem using the 0.822 atmospheres, because I say, you say, oh, there's the atmosphere, it's fine, just dump it in without thinking about the water vapor, you would have got 0.00280 moles. And you're not penalized for previous errors. Your previous errors, you forgot about the water vapor. You get the point for the moles if you calculated the moles correctly using the 0.822 atmospheres. Yes, that was a previous error. All isn't lost. You get 1 out of the 2 points for this problem. The next thing you want to know is, and the calculate the number of moles that would be produced if the dehydration went to completion. Okay, we had 0.2 of a gram. If it reacted completely, we have a 1-to-1 molar ratio. This is a stoichiometry thing that we need the moles of ethanol for. So our next step is to take and calculate the moles of methanol, which is the 0.2, divide by the molar mass of methanol, and they gave us the molar mass is 46.1. 46.1. And make sure that it used ethene. Here's the ethene, but we know the grams of ethanol. It's a pure substance. And if we divide by its molar mass, we get its moles. 0.2 of a gram divided by, you should know that automatically. And we have the moles of ethene. This is actually how much ethanol was here, and they could produce 1-to-1 that much ethene. And this makes sense because in the experiment we collected about 3 millimoles, and we could have collected 4 millimoles, but the reaction didn't go to completion. So there we've answered this question. It was that could be or would be produced if the reaction went to completion. There was the hint. If it went to completion. Let's see if we were right. 0.00434. Yep, round it off to 3 significant digits. Now, if you put down 0.004, thinking that was 3 significant digits, you'd get this problem wrong, because I am pretty sure this is the problem that they use for significant figures. If you are doing problems and your sig figs are off anywhere else, you don't get penalized. But there's one question where the sig figs do count. And my guess is that it's this one. It's just a simple grams to mole conversion. And to get a point for that just by doing that division probably wasn't worthwhile. They wanted to see, did they carry it out to 3 sig figs? And did they know that leading zeros don't count? So you would get 1 point for the correct number of moles of ethene produced. Well, let's go to the next step, which is calculate the percent yield of ethene in the experiment. Well, percent yield, that's a pretty standard chemical arrangement. We get the actual, which we did in this experiment. That's because we had an experiment. We picked up 0.00264. That's what we made. What we could have made, well, that was our other calculation, 0.0043, and then multiply by 100, and we get our answer. 0.00264 is what we produced. I'm going to divide it by my last answer. And I'm not going to bother multiplying by 100. I know it's 100. And I get 60.8%. And let's see if you're right. 60.8%. And we would get a point for the correct percent yield. But let's go back here. What if we had instead 0.0028 moles of ethene that we experimentally collected, where we forgot about the water vapor pressure? Well, as I said before, you're not double penalized, because the grader, I'm sure, will have had in their little notes saying, hey, if they forgot about the water vapor pressure, they're going to get 0.0028 moles and get 64%. Well, if you calculated the moles that were collected as 0.0028 and did this, you would get full value. So if you made this mistake on water vapor pressure, you'd lose 1 point out of 1, 2, 3, 4 points. You'd get 75%. That's level 4, level 5 work. So it's no catastrophe if you make an early mistake, because the grading is fair. You're not double penalized. I mean, if they said, okay, this is the incorrect answer because this is the right one, you would have gotten 0, but actually you got 3 out of 4. This is fair grading, and it's something that you should know. And I said, in terms of your own strategy of solving problems on an FRQ, if you couldn't figure out what the moles were here, or the moles were here, if you wrote down some number, you said it's 0.3, and over here you said it's 0.4, you could have put those two values in and gotten the point for percent yield. So answer all the questions. If you miss this one, make one up, and you need that for later on, you can use it and still get the point. So this is a strategy for dealing with a long FRQ like this, don't give up because you might have missed up something early. You can end up continuing, realizing that they'll take previous answers that you write down and use them to see if you did things correctly. They'll do the calculation that you would have done to see what the correct answer is. Well, that's A and B of this FRQ and how it's graded.